Alright, back to Haskell. Now we're doing functions as functors. Wow, I just felt now immediately my brain just went blank. We read about functors the day before yesterday, and now I just don't remember. What's a functor? Oh, right. Stuff you can map over. Yeah. Stuff you can map over. It's a box. Functor of boxes, exactly. Thanks, Colgate on tap. Right, another instance of functor that we've been dealing with all along is this is a functor. The right pointing arrow. Miss something? No. But wait, what the heck does... Oh, there is an R here. The point and then R. Yeah, what does that mean? The function type R and then the right pointing arrow A can be rewritten as... Right, it's an infix and you can rewrite it as a prefix. RA. Much like we can write 2 plus 3 as plus 2, 3, make it into a prefix. When we look at it as right pointing arrow, RA, we can see that right pointing arrow, we can see it in a slightly different light. It's just a type constructor that takes two type parameters, like either. Type constructor takes a type and then another type. Okay, Dino Tab says it's slightly different light because you use dark mode. Is it? Ah, it doesn't look very different. More than it blinds my eyes. Ah, it hurts. It hurts. Let's take it away. I think maybe because we're using the PDF. Oh. It was a pun. I didn't get the pun. It just went like this. Yeah, it's in a slightly different light because I'm using dark mode. Oh man. Oh man. Too often. I really like puns, but sometimes they're just a type constructor that takes two parameters, like either. Yeah, either is like either that type or that type. But remember that a type constructor must take exactly one type parameter, so it can be made an instance of functor. That's why we can't make the arrow type constructor an instance of functor. However, if we partially apply it to R, right, we have something. It doesn't pose any problems. Exactly. So the R stands for what? Input? I don't know. Colgate Dino Tab says, it is okay. It's more fun when the jokes are explained anyway. I agree. The jokes are more fun when you explain them. Right, it doesn't pose any problems. Yeah. If the syntax allowed for type constructors to be partially applied with sections, like we can partially apply plus by doing 2 plus, which is the same as plus and then 2, yeah, we could write the arrow R as R arrow. How are functions functors? Let's take a look at the implementation, which lies in control.monad.instances. We're seeing that word coming about again, eh? Exciting. Right, an instance of functor is I don't remember. What do we call this? The right pointing arrow R, where we map, we fmap it, fg, we take our lambda function and where x is oh man, alright. F is a function, right? G is another function. So what? We map F on... Right. Let the author explain this. Yeah. First, let's think about the F maps type. I was not in the mental state to parse that myself today, so let's have someone else explain it for us. Right. F map. Yep. It takes a function that where we get an A and returns a B, and we're right in our box, right? This is our context because we're and we're turning all the A's in our context, or the A's in our context, into B's in our context. Let's mentally replace each F. Oh, actually, could point out that B does not have to be another type from A, right? We can take one, can map +2, so it just can be another type. Right, next let's mentally replace each F, which is the role that our functor instance plays. Yeah, F does not stand for function, it stands for functor. Right, replace this with right pointing arrow and R. This will let us see how fmap should behave for this particular instance. Here is the result. Right, so we have this function that as input, and then we have return. Oh, it's confusing me. Now we can write the right pointing arrow RA and the right pointing arrow RB types as infix. R2A and R2B, as we normally do with functions. Right, what is R? R... Yeah, what the heck is R? What did we say? Function type R. It's a function type R arrow. Ugh. I don't know what any of this means. Right, now we can write it as this, as we normally do with functions. That's a function, that's a function, and that's a function, right? Turns a something R into an A. Now it notices that R is a programming language. It is, isn't it? R is a type. Yeah, but what type? I often run into this problem. We have A's, we have B's, we have X's, we have R's, we have G's, we have F's, we have... Right? All of this stuff, and I feel like I don't remember. There is a standard that is being used in this text, and I don't understand the standard. So this just looks like random letters to me. R can be any type. So why are we using R instead of A, B, and C if it can be any type? Isn't it? There is something special with R. But I don't get what is special with it. I'll get in on tab says, I don't know. Right? Because we're just a type. The function, it's a type of a function. Right? It's a function type. It's not a variable type. Well, get in on tab says, I don't really pay much attention to which letters are used. I only care about the structure. I need to operationalize, right? What is actually happening? What is the A? What is the B? I need an example to understand what's going on. What does the arrow do? What does the R do? The A do? Maybe that's another reason why I suck at math. Yeah, I can't just look at a formula and say, oh, this is just fine. I need to exemplify. There are probably some reasons why those letters are used. Yeah, A and B are usually variables. X and Y are used for number variables. F is used for functors. And a functor, this is a functor, right? This is the context that we keep. Yeah, we keep our context and change A into B. That's what we're doing. We're doing a map. Again with the maps. Yeah, we're just operationalizing our functor and making it... We're looking at how the functor works deeper down in the compiler, right? What is happening? Get in on tab says that the right pointing arrow R is the box. Exactly. This is the box. This is the box. This is the contents of said box. Right, so why are we doing this? Because we're learning about this pointing arrow. So this pointing arrow creates a box. That kind of implies to me that we have this, the box. There's a box in the box, right? The F here is a box, which means that the arrow and FA... Wait, is this a box within a box? Or is this the box? Oof. Losing track of what is going on, eh? Notrunner says the soup is almost done. Praise the soup. Praise the soup. Don't they say praise the sun? That's... we blew that. Okay. Mapping a function over a function must produce a function. Just like mapping a function over a maybe must produce a maybe. And mapping a function over a list must produce a list. What does the preceding type tell us? We see that it takes a function from A to B and a function from R to A and returns a function from R to B. Does this remind you of anything? Nope. Looks like French. Well, it reminds me of French, I guess. I don't speak French, by the way. Yes, function composition. We pipe the output of R arrow A into the input of a B to get a function R to B, which is exactly what function composition is all about. Here's another way to write this instance. Right, instance functor to R where... Wait. function composition of fmap. Now Donner says, I speak French? I didn't know that. I assume that this does not look like French to you then? This makes it clear, oh, does it? That using fmap over functions is just function composition. In a script, import control.monad.instances, since that's where the instance is defined, and then load the script and try playing with mapping over functions. Right, this whole section, I hope you understand what's going on, because I'm completely lost here. Completely lost. Now Donner says, or rather, I was trained to speak French. If you need any French actually spoken, I can translate it on Google for you. Nice. Oh, that's very kind of you, so I don't have to use Google. Right, what do we have? Type fmap. Check the type of fmap multiplied by 3 plus 100. What is this? Yeah, it's a num type, and it takes an A and returns an A. Here it's not an X and a Y, so I was completely wrong about the X and Y. Maybe X and Y is not used as numbers, but as coordinates. Yeah, when we use coordinates in a two-dimensional array or something. Map multiply by 3 plus 100, and then 1, get 303. Right, and we do it as an infix, that's the same. We do it as a composition. It's the same. Then we can show. We map show and the multiply by 3, and that's the same, but we get a string. Colgate tab says they are used as parameters rather than in type declarations. Wait, which ones? Pronouns are hard. You were saying they. Who are they? Which are they? What are they? Well, parameters. X and Y. Ah, X and Y are used as parameters rather than in type declarations. Okay. Right. Like we use X and Y as the head and the second item of a list, for example. Right, we can call fmap as an infix function so that the resemblance to the dot operator is clear. Right. Function composition still scares me. Yeah. In the second input line, we're mapping multiply 3 over plus 100, which results in a function that takes an input, apply plus 100 to that, and then multiply by 3 to that result. We then apply that function to 1. Just like all functors, functions can be thought of as values with context. Okay. When we have a function like plus 3, we can view the value as the eventual result of that function. And the context is that we need to apply the function to something to get the result. Okay. So our context is just that the function is incomplete. Colgate tab says, now you've learned that function composition is mapping function to function. Try to understand which concept is easier and you understand both. Right, function composition and mapping function to a function. That, I like the way you put that, Colgate-tab. We are actually mapping a function to a function, which makes my head spin. But I think that is probably easier for me to understand, but that doesn't mean, well, if I understand one, I understand both. Guess that's the case. Now I just need to wrap my mind around mapping a function to a function. That does not compute in here. I guess it computes on the screen, but not in here. Not yet, anyway. Right, when we have a function, yeah, we can view the value as the eventual result of the function. Context, we need to apply something to get the result. Right, in here, that something we need to apply is a number. But when we're mapping things, right, for example, we need to apply function. Wait, using fmap multiplied by 3 on plus 100 will create another function that acts like plus 100, but before producing a result, multiplied by 3 will be applied to that result. Right. Yeah, we were using... Right, we were mapping on that. We never just put these two next to each other. We actually had to map this on here. You can play around in Haskell to get a better picture. I don't think I can. No. Maybe you can. Right. The fact that fmap is function composition when used on functions isn't so terrible useful right now. Why are we doing this? But at least it's very interesting. It also bends our minds a bit and let us see how things act more like composition than boxes. Computations than boxes. I/O and right pointing arrow R can be functors. Function being mapped over a computation results in the same sort of computation, but the result of that computation is modified with the function. Before we go on to the rules that fmap should follow, let's think about the type of map once more. This one I get, right? You just had to mess around with this button. This, not button, but this icon. Now all of Haskell is just thrown up in the air for me. I don't understand anything anymore. Right. The introduction of curried function in chapter 5 began by stating that Haskell function actually takes one parameter. A function A, B, C just takes one parameter of type A and returns a function B to C, which takes one parameter and returns C. That's why calling a function with too few parameters, that is, partially applying it, gives us back a function that takes the number of parameters that we left out. If we're thinking about functions as taking several parameters again, right? I lost track of this. That's why calling a function with too few parameters, that is partially applying it, gives us back a function that takes the number of parameters that we left out. Yes, exactly. If we're thinking about functions as taking several parameters again. Yeah. So A, B, and C can be written as A to B. Yeah, exactly. To make currying more apparent. In the same vein, if we write fmap, right, take the function a to b, and then we keep our context a and b, right, boxes. But we weren't supposed to think of them like boxes anymore. Right, we can think of fmap not as a function that takes one function and functor value and returns a functor value, but as a function that takes a function and returns a new function that is just like the old one, except that it takes a functor value as a parameter and returns a functor value as the result. Right, it takes an a to b function and returns a function fa to fb. This is called the lifting a function. Let's play around with that idea in phci's command. Okay, so that's the function. And right, our value has functors. I really like the boxes analogy, right? I like the boxes analogy. For some reason, the boxes analogy are not good enough anymore. Play around with the lifting idea, where we check the type for map multiply by 2 is takes a num. This is our function, right? No, this is our type declaration. Functor a, and then the expression fmap multiplied by 2 is a function that takes a functor f over numbers and returns a functor over numbers. That functor can be a list, a maybe, an either, or string, or anything else. The expression fmap replicate 3 will take a functor over any type and return a functor over a list of elements that type. This is even more apparent if we partially apply, say, fmap plus plus exclamation point and then bind a name in GHCI. Nodeowner says 1. This soup is creamy, cheesy broccoli soup with hot sauce, freshly ground peppercorn, and a little bit of spinach stuck in. Oh, that sounds pretty good. You can think of fmap in two ways: as a function that takes function and a functor value and then maps that function over the functor value. As a function that takes a function and lifts that function so it operates on functor values. Both views are correct. The type fmap replicate 3, all right, here we go, means that the function will work on any functor. Functor f. What it will do depends on the functor. If we use fmap replicate 3 on a list, the list implementation for fmap will be chosen, which is just map. If we just use it on maybe a, it will apply replicate 3 to the value inside the just. If it's nothing, it just stays nothing. For some examples. Nodeowner says, don't tell myself about the spinach. It's a secret. Just a secret that you snuck in there. Wait, don't you like spinach? Hot spinach is terrible. Alright, something that I think I learned today is that we might have to take a break from reading the book. Because this chapter, I have no idea what was happening. Well, in this part, I have no idea what just happened. If you understood it, great. But yeah, I think maybe I'm tired from a long day of learning in Oxygen Not Included. Or this is way over my head and I need to take a step back. Noteowner says Nix REPL is a thing, by the way. Yeah, I was in the Nix REPL yesterday. I was actually thinking about that when I went to the bathroom before that. Oh man, you're right. Nix really should be part of Code Wars. Because I was overwhelmed by the Nix modules when I was looking at the modules yesterday. And I kind of need something at an easier level to start understanding Nix. Fulgituno Tab says, you mean Spinoza? Oh. Is that a play on sounds? Spinach sounds like Spinoza a little bit. Man. Right, we'll see. We might take a short break from this, and I'll have to look into this privately. That is it. I think that's time for some early lunch today. Noteowner says, I don't know that. Nice. Spinoza? That's almost like noise. No, I don't know. It is time for some lunch. So thanks for hanging out, and yeah, have a good one. Cheers.